Hello everyone, welcome back to Computer Vision and Image Processing subject, Regulation R23. In the last class, we have discussed about various edge detection techniques in under image processing. Today, we'll see about one of the important concept, object detection using CNN. This is applicable for image, input image as well as video input also. So let us go to the today's lecture. We'll see the mathematical analysis with example tracing up to the calculating the loss function values for both binary classification as well as multi-class classification. This is the today's session agenda. Introduction to object detection, the difference between template matching as well as automated feature extraction using filters through CNN, convolution neural network, the convolution layer, different kinds of layers which supports in this CNN model. Activation function, mainly I'm choosing a relative activation function where it takes negative value as 0, and example tracing followed by the references and the feedback link. So if we come before going to the object detection using CNNs, if we choose the previous one, technique called as a template matching, there pixel to pixel extraction is there, which is very a complicated one and a complex one, because there it will work always on a same size, same orientation, and if the illumination is same, then only this kind of techniques will be possible. But in real time, it depends upon the situations and the viewpoints and the scaling and oscillations at all and all. This kind of fixed size orientations will not be possible. That's why we have to make this technique in an automated way using filters through a convolution neural network. So it is always there through kernels, which also contains weights. Image contains the pixel values, the raw pixel values, which you want to extract through this pixel, the weights from the kernel, so that it is capable to detect edges, texture, and the objects which are embedded in the image, input image, so that you are doing image classification or object detection, and it is acts like a backbone model for entire convolution neural network architecture. When it comes to the convolution layer, mainly it is focusing on a mathematical equation which is considered as a weighted sum. There, a simple multiplication followed by the addition is exist by applying the filter weights on the corresponding image, and you are not taking the filter size and the image size as equal. The filter size, for example, which is like 3 by 3, and the input size is like 8 by 8. The 4 by 4 kernel is applied on each and every convolution block which covers the entire image by applying a stride value as 1 or 2. So like by applying the different kinds hyperparameters, we are making the kernel operation, the convolution operation in a smoother way to extract to extract the features which are available in that input image. So as we discussed previously, nothing but the relative activation function. This returns max 0 comma x. If x is negative, it returns 0. If x is positive, it returns x. As simple it is. Through pooling layer only, you're doing downsampling where you're reducing the size of height and the width, nothing but the spatial dimension, so that yeah, we are moving to the next layers up to the fully connected layer. There we are converting the dimension of 2D features into one dimensional. So there in that fully connected layer, we are applying the classification, whether it is binary or multi, or where it will be a regression. There the model will going to give a logist to take the decision what is there in that image. So to convert this entire theory into a mathematical example, here I am trying to take a input image 4 by 4 and the kernel is 2 by 2. There the weights 1 minus 1, 1 minus 1. So 1 represents a bright, minus 1 represents a dark. Likewise in the combination, the kernel weights are designed with by taking including the bias value also. So if you see here in the example, the input image size is 4 by 4 and the kernel is 2 by 2. So the 2 by 2 is applied on the first window. The first window of 2 by 2 from 4 by 4 is 10, 20, 0, 50. This one we are calling as a top left, and the top middle which contains pixels by covering 20, 10, 50, 50, and the top right is covering pixel values with a 2 by 2 on 4 by 4, 10, 0, 50, 0. So likewise you are filling the top row by considering top left, top middle, and the top right. Now when it comes to the middle one, which contains middle left 0, 50, 0, 50, center exactly the center 50, 50, 50, 50. These are the pixel values, and the center towards middle right, which contains 50, 0, 50, 0. So that you are going to be get the extracted pixel values from the middle. Now it comes to the bottom, which there also are having three things, left, middle, as well as right. Now it comes to the bottom left, which contains pixel values 0, 50, 10, 20, and bottom middle 50, 50, 20, 10, and bottom right 50, 0, 10, 0. There you are applying the convolution operation with respect to the kernel weights along with bias by applying the multiplication followed by the addition. For the first, let us discuss the first one. Nothing but the top left. So here you are multiplying the pixel values 10, 20, 0, 50 with the 10 minus 1, 1 minus 1, and 1 minus 1 along with by adding the bias. So that the final mathematical equation will be 10 into 1, 10, 20 into minus 1, minus 20, 0 into 1, 0, 50 into minus 1, minus 50. So that you are going to be get the final result as by adding a bias, it will be minus 59. For example, let us take the center one. So center contains all the pixel values 50. If you multiply with the kernel weights, 50 into 1, 50, 50 into minus 1, minus 50, 50 into 1, 50, and the last 50 into minus 1, minus 50, so that the center will give you the value as 0. So 0 plus 1 bias will be the 1. So likewise you are applying the convolution operation by taking the filter weights on the input image, which contains the raw pixel values along with the bias. So after applying all this, you are going to get a 3 by 3 feature map, which contains the extracted pixel values by applying the convolution operation. So if you apply ReLU activation function on this feature map, as we discussed previously, the ReLU will return max function 0, x. So if you see the first column, all are negatives. Now negative pixel value. Now it becomes 0. So 11, 1, 11 in the second column, which are positive, the same will be retained, and the third column doesn't contain any negative value, so it will be retained as it is. So after applying the convolution operation, I am applying a pooling layer. I am choosing max pooling, so that by applying the max pooling with the filter size 2 by 2 in that kernel 2 by 2, you are choosing the maximum pixel value. So here if you take the window 1, which contains 0, 11, 0, 1, among which 11 is the maximum, and the second window 11, 61, 1, 101, and the maximum is 101, and the third window 0, 1, 0, 11, and the maximum is 11, and the fourth window 1, 101, 11, 61, and the maximum is 101. So likewise, finally you are going to get the pooled values by applying the max pooling layer with a size of 2 by 2 filter. Only 4 are there that will be converted into a vector with like a column or a row vector, which contains here 1 row by 4 columns, 1 by 4 the dimension. So these values will be given for the final classification along with the weights for calculating the final predicted value by applying the binary classification activation function like sigmoid or multi-class activation function by considering the softmax. So this is the final vector 11, 101, 11, and 102. So by considering this, we are going to be see the classification part. There, here I am applying a binary classification. Only two categories I am trying to take, dog as well as cat. So four features are there in my final flattened vector. So that here if I want to take an example with respect to weights of dog to define the binary classification dog versus cat. So here 4 weights are there along with bias. So those weights of dog and the features extracted by the final convolution layer will be multiplied weights into input plus bias, so that you will get the final logit value for dog as 83.2. So now when it comes to the cat, in the same manner, you will get the final logit for a cat as minus 22.8. So this is binary classification function. To decide the final predicted value, you have to apply the sigmoid activation function, as you know. So after applying the sigmoid activation function, this one I'm considering as z. So that here if I substitute in this sigmoid activation function, I will get a 0.99 probability and near to 1, and the cat is near reaching to 0. So the final probability is telling the given input image is a dog. So let us see the multi-classification part followed by the loss function to identify whether the model contains less loss or high loss. Now, when it comes to the multi-class classification, the name defines more than 2 categories, so that here 3 categories are there: dog, cat, and bird, along with its weights and the bias. So the same input, the final vector will be multiplied with all the weights coming to 3 categories: dog, cat, bird, by adding the bias, so that the final logit for dog is 5.32, the final logit for cat is minus 2.16, and the final logit for bird is minus 1.73. So these logits will be substituted to the will be given as input to the softmax activation function. There you are applying the mathematical equation e power z by sigma with respect to all the categories e power zi. So that calculating the numerator part and the denominator part will be separately needs to be calculated. Why? Because the denominator part is a common one, and only the numerator part, the corresponding category only changing. When it comes to the logic with respect to the dog, cat, and bird, all the values are calculated. You can follow here for the 3 categories, so that you are going to be get the highest probability for dog, which is 0.9986, and the very less probability for cat and bird. It means the given input image is defined by the model, which is a dog. Now, when it comes to the different kinds of classes with respect to the loss function, for the first we will see the loss function for binary. After that, we will see the multi-class. So when it comes to the binary, there we have to apply binary cross entropy log loss. This is the mathematical function which defines the both category classes. So the predicted value by the previous example, it is 0.998, which is near to 1, but the actual value is 0, which here itself it defines the actual value is 0, but model is predicting it as 1. So it is a misclassification, so that we can see by applying the mathematical application how much loss it is providing. So if you by taking these values, actual value y as 0 and the predicted value as 0.998, so the final loss is 2.69, which is very high. Now when it comes to the multi-class classification, here the actual vector which contains 1 by 3 for dog, cat, and the bird, here it is given as 0 1 comma 0. So the actual input image which I am giving to the model is cat, but my model is predicted as dog. So here also a misclassification is there. My model is giving highest probability for dog and very less probability for cat and bird, but the actual value is a cat. So after applying the loss function by using the multi-class classification, by taking the y vector and the predicted y cap, the finally I'm going to be get the final loss is 7.60, which is very high loss. So this is the main example tracing by taking an input image and the filter weights by applying. After that, we are applying the convolution operation, pooling layer, followed by the flatten layer. The flattened layer always gives the 2D, converts, it won't extract any information, it simply converts the 2D part to one dimensional. So after that we applied the kind of mathematical equations, how to produce the logits by applying the weight values for the respective animal categories. Now if you see the loss function also, which we defined for separately for binary classification as well as multi-class classification, there intentionally we have taken the actual value as completely opposite to the predicted one, which useful to identify whether the model is going to for misclassification or proper classification. So this is the example 2 you can refer. Here I am going to give input size as 5 by 5 and the kernel is 3 by 3 with respect to the brighter pixel values, gray pixels and the dark pixels, by taking the stride value as only 1 and the bias value as 2. So simply you are applying this 3 by 3 on the first left window. For example, the left window pixel values contains 1, 2, 3, 0, 1, 2, 1, 2, 1. So top middle nothing but 230 123 210. So top right is nothing but 301 231 100. Likewise, you change the stride value with only one to calculate this by applying the same procedure whatever we discussed now up to the loss. So for calculating the loss value, you can take your own categories and the own weights to identify how the mathematical equation for binary classification sigmoid is working and for the multi-class classification softmax is working. So let us please try this example with your own weights coming to the both category of binary and the multi to identify the class for finding whether your assumptions are going to be generate the multi classification final classification output or misclassification output. So these are the references which I followed to prepare this material. If you have any queries, you can respond to this form link which I mentioned here for the further communication. Thank you.